Okay, now let's continue with the case of a subsidy. And you can see the final result here in the left panel, but let's just derive it one by one because it's a little bit convoluted. So if you look here at the right panel, we have again our original demand and supply. And now we have a subsidy, and the producers get a subsidy of 2. So now we have the case of a subsidy of S equals 2. So now we know that a subsidy pushes down the supply function. So we can push that down by 2. Okay, so maybe this needs to go maybe here. So the new supply function is this one, so I just gray out the old one a little bit. Let's just make that. So now what is the new price? So the price is 5. So and the total quantity turned over is also 5. Okay, so now we can do our welfare analysis. So we have here again our parameters. And now we have the case of a subsidy of S equals 2. Okay, so first thing we saw is that the new price is 5. And the quantity demanded and the quantity supplied and the quantity turned over is all 5. Okay, so, and again, this was the old supply, and this is the supply plus subsidy. Okay, so the consumer surplus, that's pretty easy. The consumers, they pay now 5, and they get so the consumer surplus, they will pay 5, and the consumer surplus is the area underneath the demand function, all the way to the quantity turned over, up to 5. So we take this triangle here. So the green triangle is the consumer surplus. How big is this area? It's 1, 2, 3, 4, 5. 5 times 5 over 2, 12.5. And if you still remember, compared to the market equilibrium, consumer surplus was 8, so that's a gain of 4.5. Okay, so now what about the producer surplus? So the producer surplus is, again, on the supply function we have the true reservation price. So that means the net price that the producers get, they get 5, but for every unit that they sell, they still get the subsidy. So the real price that they get is actually 7. So that's the price that they get. So So there's some overlap now. But this area here, so if I remove quickly the consumer surplus, we can see this is the real supply function. That's the real reservation price. And even though people pay 5, the producers actually get a price of 7.5 plus the subsidy of 2. So this producer surplus is 12.5 as well. And that's also a gain of plus 4.5. Okay. So let's put back the... So now we said earlier that total welfare is consumer surplus plus producer surplus plus the tax revenue. But now we need to subtract the subsidy, because the subsidy has to be paid. That's not just redistribution. So that is being fed out of welfare. And so even though the price is 5, we have to pay 5 times a subsidy of 2, so that's a total of 10. And that is equal to this triangle, to this rectangle here, which is that much. And that is supposed to be red. Maybe I can bring that to the front. Okay, that makes it a little bit different. So when it comes to the subsidy, the areas become they overlap a little bit. But again, so here this was the consumer surplus. Here that was the producer surplus. And here that is the total cost of the subsidy. The difference between the price that people pay at the cashier and what the society still needs to pay the producer. So that's a cost. So we have to subtract here the subsidy cost. Okay, so now we have here the subsidy cost, which is 5 times 2, which is 10. And of course there's no tax revenue, so total welfare is now 12.5 plus 12.5, that's 25, minus 10, that's 15. So we have again a loss of -1 relative to the market equilibrium. So here in the market equilibrium, we had always 16. Okay, so we have a deadweight loss, and that deadweight loss, as you probably can already sense, is again this little triangle here. And let me see if I can put that. Yeah, it's difficult to. So well, let's bring that to front. So we can't really see it, but this triangle here, what is unique about this deadweight loss is that the deadweight loss now, for the first time, it is a deadweight loss, which is essentially a deadweight loss from inefficient overproduction. So this deadweight loss here is inefficient overproduction because the market equilibrium was here. So now we produce too much. So why is it a deadweight loss? And as you can see, what happens is that if you take a look at the true supply function, so here on the supply function, we have here a lineup of our producers according to their willingness to sell their reservation price. That's the true reservation price. And now the true reservation price continues here. And what we do is we basically lure in consumers who are lined up here. So this is the true willingness to pay. So the true willingness to pay. So now we basically match people whose true willingness to pay is less than the true reservation price of the producers. And that is created by the subsidy, which lures people into more demand than what the true costs are, and therefore we have essentially a deadweight loss from an inefficient overproduction. So the deadweight loss in a subsidy is essentially a deadweight loss from inefficient overproduction. So the deadweight loss in a subsidy is essentially a deadweight loss from inefficient overproduction. So we lure in both people into the market with a reservation price which is actually higher than people's willingness to pay, and that creates the deadweight loss. Okay, so next we move to another concept, which is externalities, and that is particularly relevant in environmental economics. And we have to think now completely new. So now, as we talk about externalities, we no longer anymore reference everything to this scenario. So this is now over. So now the market equilibrium is now no longer anymore the reference case, because we essentially have a new reference case, which is which includes a negative externality. Okay, so let me first clear this. Okay, let's get rid of all our areas that we just need for I just need to clean up here quickly. I can actually delete that here. And that is again. Okay, so now I need to get rid of this one here. Okay, so I think now we are ready to go again. Okay, so now we have the case of a negative externality. So we have a negative externality. Negative externality. So what is a negative externality? A negative externality is a non-paid for social cost to society resulting from economic activity. So a standard example is that like a chemical plant emits pollutants into a lake, and that lake kills fish, and now people eat the contaminated fish, and there's a public health problem, let's say. So the way we model a negative externality in economics is by shifting up the supply curve by the social cost. So in economics we call this supply curve the supply curve based on private cost. So this is raw materials, it's based on, so the supply curve is the reservation price that the producers have to charge in order to cover all their costs. And those are the private costs now. So that's like the raw materials, rent, wages, those kind of things. But now, if there is a cost to society as well, what we do is we shift up that supply curve by the social cost. So this one is the supply curve plus the social cost. And this is now our market equilibrium. This is what we should have. So we should, if this is the true economic cost, that not only has, let's say, the cost of producing chemicals, but also the cost to society, taking care of all the public health issues and those costs. So then, in this case, the social optimum, the market equilibrium, should actually be at this point. And this is now becoming our reference scenario. So let's first take a look at the market equilibrium or the social optimum. So the social optimum, okay, so the thinking goes like this: the true price should be 7. And the true quantity turned over should only be 3. Because this is the supply function which is relevant from an economic perspective. And so in other words, the problem with an externality is that we produce too much of a bad thing and we sell it at a price too low. So the true price, the market equilibrium price, should be 7, and the equilibrium quantity should be 3. Okay, so now we have here the social optimum, values. Okay, so the price should be 7. The equilibrium, the equilibrium quantity, which is quantity supplied and quantity demanded, just for be consistent with here. So that is all 3. Quantity demanded, quantity supplied, and quantity turned over should only be 3. So then how big should be consumer surplus? Well, consumer surplus should be this one here. So consumer surplus should be 1, 2, 3 times 3 over 2 should be 4.5. What should be the true producer surplus? Well, the true producer surplus should be now this one here. So So the producer surplus should be 4.5. So therefore, total welfare, total surplus should be 9. So this is what the social optimum should be. Okay. But now we have to ask the question, what is actually taking place? So the question is, with a negative externality, but what happens? So the parameters associated with the non-social optimum or negative externality scenario, negative externality. Okay, so compared to the social optimum, what happens is the market clears here. Because the chemical plant is not being held accountable for anything. So it doesn't face any social cost. So okay. So this is the equilibrium. So now consumer surplus is this area here. Okay, so what do we have so far? We know that the price without the internalization of the negative externality, the price is 6. So now we have this price here. The price is 6. The quantity demanded and the quantity supplied and the quantity turned over is all 4. So here. And now we said consumer surplus is 1, 2, 3, 4. 4 times 4 is 16, over 2 is 8. So this is consumer surplus. So now what about producer surplus? So that's this blue area. So producer surplus is also 8. Okay, but of course now welfare doesn't mean that we have 16 in welfare, because you can see the social cost, which is, so now what happens is we turn over 4 units of activity, and and each unit of activity turned over carries the social cost of 2. So that means we have here this red area, total social cost. And by the way, this area should be up here. Okay, let's just do it again. So Okay, so let's derive everything again. So, okay, the equilibrium price is 6 without internalization. Okay, so therefore we said consumer surplus is this triangle and the area is 8. So then producer surplus, I put it in here, but I'll put it in there, which is the same, because the producer surplus is, the way you can think of an externality is the consumers, the producers, they get 6, but then they can pollute the environment for 2 units, for 2 units per unit of production for free, which is just like an increase in the price. So this area overlaps. So now the producer surplus is 8, but again, it's the same as here, but I'll put it there because I like to think of the price that the consumers get, the price that the producers get, as the price at the checkout, 6, but then they can pollute the environment for free, and that's a cost reduction or a unit price increase. It's the same thing. So they technically get 8 because they can, the value of 2 in pollution they get for free. And lastly, the total subsidy is now 4 times 2, which is 8. Another subsidy, the social cost. The social cost is 8. Social cost is 8. So now total welfare is consumer surplus plus producer surplus minus the social cost. So 816 minus 8, so that's 8. And relative to the market equilibrium, that entails a deadweight loss of -1. So now where do we see again this deadweight loss? So that's this triangle here. I just make a new one. Actually, I can draw it. So the deadweight loss is this triangle here. And again, what we have in a negative externality is that we have a deadweight loss from an inefficient overproduction. So the saying is like, in the presence of a negative externality, we have too much of a bad thing. So the deadweight loss is the result of overproduction. That is inefficient. That is inefficient. So the deadweight loss is the result of overproduction that is inefficient. So we should produce only here. We should produce here, but we produce there. But because the true costs are this one, we basically have producers that are here, and they serve inefficiently producers whose willingness to pay is actually much less. If they knew that there's that the true social cost originate from the chemical plant, which producers probably don't know where it comes from. Okay, so I hope that is clear. So that's a case of a negative externality. And what is unique here is the fact that we don't compare it anymore to a market equilibrium, but we first need to find the social optimum, and then we compare it with what's happening. And so now what we said is, when we calculate welfare, actually I write it now down here, when we calculate welfare, we said that is equal to consumer surplus plus producer surplus plus tax revenue minus subsidy cost. And what we also need to do is we need to subtract social cost. Okay, so one other final word about a subsidy. Earlier we said that a tax creates a deadweight loss, but if a tax is being used in order to internalize a negative externality, then that would be perfectly fine. So a tax to internalize a negative externality increases welfare. So a tax to internalize a negative externality, that would increase welfare, because, and we can see that so because what would happen is, so we said this is the private supply. And now if this is the social cost, then, we said this was the supply plus social cost. But now we just say, no, we don't use the social cost, we make that a tax. So now if that becomes a tax, so now what happens is, now the new price will be again 7. So this is our price, 7. The market clears at 3. Okay. So now what happens is, so if we do a welfare analysis, so, and by the way, that idea of a tax is known in the literature as a Pigou tax solution. Pigou, P-I-G-O-U, Pigou tax, that is equal to the social cost. So in our case, equal to the 2. Okay, so now what do we know? Well, the price obviously is 7. The quantity turned over, which is equal quantity demand, quantity supplied, is now 3. So now what is consumer surplus? Well, consumer surplus is now this one. So that's 4.5. What about producer surplus? It's this one here. Or if you want to, you can put it here, because even though the producers, they get now at the cashier 7, their net price is again only 5. but producer surplus, the blue area, is 4.5. So now we collect 3 times the tax of 2. So that's this red area. So the tax revenue is 6. But of course that is also equal to the social cost, because we have 3 times the social cost. So the social cost is 6 too. So now if we use again our formula that welfare is equal to consumer surplus plus producer surplus plus tax revenue minus subsidy minus social cost, consumer surplus, producer, tax revenue, subsidy minus social cost. Okay, so now we have here 4.5, 4.5, tax revenues 15, social cost minus 6, 15 minus 6, so welfare is 9, which is the social optimum. So a tax, in most textbooks they will tell you that a tax to internalize a negative externality, that increases welfare. But there are other ways to do it too. But in terms of, textbook logic, that's definitely true, and it can be nicely illustrated. Okay, so now let's turn next to our final event, which is a positive externality. And for this I need to create a different diagram, and I'll just do that in a separate video, so that the videos also don't get too long.